Hi, this is Open Up Resources, Unit 1, Lesson 3 for Algebra 1, Growing Dots. We're going to start with a jump start. Which one doesn't belong? Well, if I look at all these, I kind of work out 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that equals 160. 2 times 2, or 2 to the second power is 4. 5 times 4, 160, 4, 8 times 20, 60. This one all equals 20. Those all equal 160. So half, 1/4, a fourth of 2 times 5, that's 160. So really the only one I'm seeing here that doesn't equal 160 is B. So I'm going to go ahead and put on here, make this slightly smaller. Let's do green. So doesn't equal 160. 2 times 2 is 4. 4 times 5 is 20. So a little bit bigger here. There we go. Okay. I might actually crease this just a tad. Here we go. All right. Is there any others that I could say don't belong? Well, this one is the only one without parentheses. Parentheses, did I spell that right? Nope. No. This one, let's see. So one without parentheses. This is just a 2-number product. This one kind of has everything. One with exponents and actually the one with fractions, right? Fractions. Fraction. This is kind of the only one that's a little bit, I guess this one has 3, 6 factors, 2 with an exponent, 2. We'll just say this one is only one, 4 factors. All right. So there's different ways we could have done all these. Kind of a reason why each one of them couldn't belong. Okay, so our learning focus today is we're going to model a sequence of figures using tables, graphs, and equations. We're going to label a diagram to show I see a pattern. And again, look at those mathematical representations on how to see the pattern changing. So here we have a picture. I'm going to zoom this in just a little. It's almost can't see enough of it. Okay. Beginning. So I'm going to go ahead. I like to write on here. Have mine 0 and I have 3. So 1, 2, 4, 6. At 2 minutes, 4, 8, 12. 3 minutes, 8, which is 24. At 4 minutes, I have 16 times 3, which is 48. Okay, so describe and label the pattern of change you see in the given sequence of figures. Well, I'm noticing that I can either do a +3 or a ×2. Well, plus 3 does not give me 12, but a times 2 gives me 12. So if I do a times 2, times 2, times 2, that gets me 24, and a times 2 gets me 48. So, my text box here, I see that each minute doubles, or a times 2, to the previous. Okay, so assuming the sequence continues, how many dots are there going to be at 5 minutes? Okay, well, 48 times 2 would be 16, carry the 1, 96. So I should have 96 at 5 minutes. All right, so now we're going to model these. Let's see how we model them. I'm going to go ahead and do my table here. And we have minutes, and we have dots. 2, 3, 4, 5. And when we start with 0 or 1? 0, we had 3. 0, we had 3. 1, we had 6. 2, we had 12. 3, we had 24. And 4, we had 48. So if I go to graph these, oh, that's a bad one there. Try that again. Right here. All right. So I'm just going to go 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. We knew 5 went up to almost 100. So 3, 4, 5, 6, 7, 8. 80. Doesn't quite get us up there. It's all right. 20, 30, 40, 50, 60, 70, 80. So 0 is 3. Find my colors here. So somewhere right down here below that 5 mark. 1 is 6, just above it. I feel like it's a little off. I need to zoom this in a little bit. There we go. Now I can see it a little better. Back to my drawing. 1 is 6. 2 is 12. 3 is 24. So it's just under this line. 4 is 48. That's a jump. And then 5 is 96, and that's 80. Woo! Hit a button. That'd be 85, so 96 is going to be somewhere up here. So notice how my line curves pretty steep on that. Pretty big jump. Let me go from there. So our recursive equation, I'm going to go ahead and do it a couple different ways. So the first way I'm going to do it is kind of the terms for it, where we say next black, so then I can highlight them. Next equals previous times 2. Okay, now the other way I'm going to write it is going to be down here, and I'm going to highlight the different parts as we do it. So we want to start off by writing out what our first term is. That's going to be this guy up here. So f of 0 equals 3. That's what we're starting with. Now, then we want to do my next equals next. F of n. We don't know what it is, but we know it's going to be equal to the previous, which was the number prior, and then it's going to be a times 2. So here's how we get all the pieces to this type of equation. So if I were to put in a 1, just going to do one of these down below. So f of 1 should equal f of 1 minus 1, which is f of 0, times 2. Well, if I look back, f of 1 up here is the answer to the previous 3 times 2. It is. And that's something here I'm going to show. Let's do this guy. With my table, I can see a little bit easier what my pattern is. There we go. So that times 2 ends up over here. So it's kind of the way it looks on here. All right, so then our explicit equation for it is f of x equals, well, how does this work? Let's set this up previously. I'm going to zoom back up here to where we have our table and kind of make my chart that I did earlier, the last one. So I start with 3. I'm starting with 3. So 1 is my 3, and I timesed 2 to it, right? Yes. 2 is my 3 times 2 times 2. And my 3, right over here, was my 3 times 2 times 2 times 2. All right, so just like on my last one, I noticed 1 minute, I had 1 2 I multiplied. At 2 minutes, I had 2 2s I multiplied. 3 minutes, I had 3 2s I multiplied. So I always have a 3 in the front that is constant. So f of x equals 3, but I'm timesing it by 2 however many times. Let's be consistent with our variables here. Let's do ins. So if my first minute, I needed 1 2. My second minute, I needed 2 2s. My third minute, I needed 3 2s. And just to make sure, is that true? First minute, 1 2. Second minute, 2 2s. 3. And how I show a times 2 times 2 times 2, that's exponents. So now we're using exponents with it. So there is our equations there. I'm going to skip the ready for more on this one and go jump to the takeaways, and then we'll come back. So our takeaways for this specific one, let me go back here. Geometric sequence. What is that? It is a sequence of numbers with a common ratio this time between outputs. So that table, when we make the table, it shows us that common ratio of 2. So if I scroll back up, see how this table showed me I had the common ratio of 2. Okay, the explicit equation. What that looked like was f of n equals, and we knew we had a 3 times 2, and we do the little caret, as we call it, to the n power. So that's how we show our exponent on here. The recursive equation is our next equals previous times 2. And I'm also going to draw our recursive f of 0 equaled 3. Our next is the previous times 2. Okay. And then our graph, the shape of it this time is curved. So those are kind of the big pieces on this one. So now that we've done that, let's try our ready for more. Are you ready for more? Write in recursive, excuse me, and explicit equations to model the pattern. The diagrams were relabeled this way. So, similar idea as to what we just had, only this time 1 has 3, 2 has 6, 3 has 12. So let's go ahead and draw our corresponding one over here. So 1 equaled 3. 2 equaled 3 times 2. 3 equals 3 times 2 times 2. So my guess is 4 is going to equal 3 times 2 times 2 times 2. So now what I'm noticing is if I have a 2 here, I have 1 less over here. If I have 3 here, I only need 2 2's. If I have 4 here, I only need 3 here. So notice how we have a different, just say 2. 2 means I need 1. 3 means I need 2. 4 means I need 3. So I need 1 less 2. So how that looks when we go to write it, for our explicit, it's going to be our f of n equals, I still have my common 3, right? 3 times, and I'm still multiplying by 2, but instead of just the term number, n, I actually want 1 less. So I don't want to multiply by any 2's on the first minute, so 1 minus 1 would be 0. I only need to multiply by 1 2 the second time, so 2 minus 1 is 1, and that works for there. So now for my recursive, this time I'm starting with f of 1 equals 3. My first term is a 1 this time. So now my next one is my previous, and we still have the times 2. All right. Fun stuff on there. Okay, so let's do our retrieval. So use the table to find the indicated values. Okay, so f of 1, this is my x value. So I'm looking for a 1 over here. So my answer is negative 13. Okay, so for this one, I need my x value to be a negative 2. That's this guy right here. So that means my answer is 8. Well, for this one, I need my answer to be 1. I need the 1 on this column. So that's actually this guy, making my x equal negative 1. So if x equals 2, then what is f of x minus 1? So I'm going to substitute, nope, different color. I'm going to substitute 2n for x. So that means I'm looking for x of 2 minus 1, which 2 minus 1 is 1. So I really want f of 1. Well, that's the same thing we had right up here. So it's going to equal negative 13. So that means my previous one, what is my, x is 2, then I need to take my previous one plus 7, or minus 7, I guess it looks like on here. All right. Fill in the table for the explicit function. Let's go ahead and I'm just going to substitute in all those numbers for x. So negative 4 to the, there we go, 0 power. Anything to the 0 power equals 1. Negative 4, notice it's in parentheses, to the first power is my same number. But negative 4 to the second power really means negative 4 times negative 4, which is going to give me a positive 16. Okay, negative 4 to the third power means it's going to have a negative times a positive, negative times a negative times a negative, which these two would make a positive, times a negative would give me a negative answer. So 16 times 4, think for a second, is negative 64. And then negative 4 to the fourth power, got negative times negative times negative times negative. This one's a positive. These two make a positive, so my answer will be positive. So 64 times 4 is 256. And that's it for the retrieval. Thank you for joining us today, and we'll see you next time.